Hello everyone, welcome to MemoNeet. So I'm Prajita, your chemistry SME, and welcome back to our another video lecture of chemistry. So students, as you know that we are now preparing for BPT 5, that is on 30th June. So tell me, how is your preparation going on? I hope you are studying well. But students, I can't see that because in the last video session, I told you, I just gave you a very simple question from NCERT book and I just told you to give me the answer in the comment box, and I have not got even one answer. So it means that you are not preparing well for the exam, or you are not watching the video lecture completely. So the question I have given you in the end, so I want everybody to at least comment on that, like give the answer. It's a very simple question. I told you that 2 minutes will be required to solve that question. See, we are putting in so much efforts for you people. We are designing the lectures, making it easy for you to understand. So at least you can put in your 2 minutes and do what we have asked you to do. So solve that question, okay, and give me the answer in the comment section of the first lecture of electrochemistry, okay. Then come back and then start with this second video lecture, okay. So today we are going to start with the second video lecture of electrochemistry. Let me give you a quick recap of what we have done in the first session. So in the first session, we talked about what is electrochemistry. Then we talked about the electrochemical cell. Okay. So how this electrochemical cell is constructed, how the redox reactions takes place in the electrochemical cell. Then we saw what is the standard electrode potential, or how to calculate the standard electrode potential or electrode potential of a galvanic cell. Okay, galvanic cell is nothing but the electrochemical cell only. So we had discussed about standard electrode potential. Then the series also we have discussed. Based on the series, which one will act as a reducing agent, which one will act as an oxidizing agent. That is a very important topic. So like focus on that as well. Then we discussed the Nernst equation. So using the Nernst equation, we can calculate the cell potential or the electrode potential. Not the standard one, we can calculate the electrode potential of the cell. And then we saw how using the Nernst equation, we can calculate the equilibrium constant and the Gibbs free energy change for any reaction taking place in the electrochemical cell. Okay. And then after that, now today I will be talking about the electrolytic conduction. So our today's topic would be electrolytic conduction. So there are few terms that we must know about electrolytic conduction. Okay, we will be discussing those terms. Then we will be talking about the electrolytes, how to find out the conductivity of the electrolytes. Then we will discuss the Collar's law for strong, weak electrolytes. Everything we will be discussing in today's session. Okay, but I want you to be actually well versed with the previous topics. For that, please go and watch the first lecture. And if it is not clear, please comment below your doubts that ma'am, this topic is not clear, or can you make a separate video on this particular topic. So you need to tell me, right? If you are going to tell me, then we can do that. So at least comment. You have not even commented the answer. That was a very simple question. So I want everybody to comment in that video and what will be the answer for that particular question. Okay. So then we will be starting with our today's session. So students, when we talk about electrolytic conduction, there are few terms that we need to understand, right? What are the few terms that we need to understand? Let us see that. So students, you might have studied of these terms, that is electrical resistance and conductance in physics, right? So resistance means the hindrance to the flow of current, right? And if I talk about resistance, so it is V upon I, right? Voltage upon the current, which is expressed in ohms. So ohms are the unit for the resistance. All right. And then conductance is actually the property of material by virtue of which it favors the flow of current. Means it will be inversely proportional to the resistance. Means the reverse of your resistance will be the conductance. Okay. So the units of conductance we use are Siemens. Okay. This is usually the units which we are using for conductance. Now you know students that this resistance, it is actually directly proportional to the length of the conductor, okay, and inversely proportional to the area of cross section. Then if I remove this proportionality sign, we get rho. So okay, this is rho, a Greek symbol. So here rho L upon A. Now what is this rho? So this rho is the specific resistance or resistivity of the conductor. Okay, so we will be talking about the specific resistance or resistivity instead of the electrical resistance. Okay, so now this rho, if I want to calculate the value of rho, so it will be rho R A upon L. So from here I can say that resistivity of a conductor will be the resistance shown by it when the length of the conductor is 1 meter and the area of cross section is 1 meter square. Then what is the resistance? That will be the specific resistivity of your substance. Okay, like if we can say here also, we can talk in the terms of centimeter as well, students. So if length is 1 centimeter and area of cross section is 1 centimeter square, then rho is equal to R, means the specific resistance will be equal to the electrical resistance. Okay, so in this case we will be like volume will be 1 centimeter cube. So if we are talking about in the solutions, क्योंकि यहाँ पर तो we will be talking about solutions ना in chemistry, we are not talking about wires and all. So if I talk about volume, so volume क्या होगी इस case में 1 into 1, so it will be 1 centimeter cube. So what we can say is that the resistance offered by 1 centimeter cube of the electrolytic solution will be known as resistivity, because you know centimeter cube is the unit for volume. Right, so what is the resistance that is offered by 1 centimeter cube of the solution? That will be the resistivity, and the unit will be ohm centimeter, ohm per centimeter, sorry, right? So ohm per centimeter will be the units of resistivity. So actually students, ohm per centimeter nahi hoga, right? If I calculate the unit, so it is rho, like resistance ka unit hota hai ohm, area square ka centimeter square and length ka centimeter. So isko cancel karenge, so it will be ohm centimeter. So rho will be ohm centimeter in this case. Okay, that will be the unit. So we will be talking about the resistivity in this case. Now the another important term that we will be talking in the case of electrolytic conductance is conductivity. So conductivity will be the reciprocal of the resistivity, right, or the specific resistance. So we call it as specific conductance also. It is denoted by kappa. Okay, this is another symbol kappa that we use, which will be equal to 1 upon rho. So if I put the value of 1 upon rho, so here in this case it will be 1 upon R into L upon A. So that will be your kappa. Okay, now what does this thing means? I will explain you this G and G star. So 1 upon R, so we just see कि ये क्या होती है, conductance of the cell, right? 1 upon R, just see here, 1 upon R is the conductance of the cell, and L upon A is known as the cell constant. Okay, cell constant, which is G star. So G into G star. So in this case, we can say that the specific conductivity of a solution will be defined as the conductance offered by 1 centimeter cube of electrolytic solution. Okay, here in this case we are talking about the conductance offered by 1 centimeter cube of electrolytic solution. So cell constant kya hai in this case? L upon A, that I will just discuss with you. Just wait for some time that what is cell constant. Okay. Then molar conductivity and equivalent conductivity also I will share with you. But before that, let us discuss about the electrical conductance. So class, जो अभी तक हमने electrical conductance पढ़ी, which is through the metals, it is called metallic or electronic conductance. And why it is? Because it is because of the movement of electrons. Okay. So this electronic conductance will depend on the nature and structure of metal. You know that all metals, they don't have the same electrical conductance. Some have more conductivity, some have less. Okay, that depends on the number of valence electrons per atom, and it depends on temperature also. So you know that when temperature increases, the conductance would decrease. Okay, so that will happen in the case of metallic conductance or electronic conductance. So as the electrons enter at one end and go out at the other end, the composition of metallic conductor remains unchanged. So in this case, another important difference is that there will not be any change in the composition of metallic conductor. Okay. Now, if I talk about water, so it has very small amount of hydrogen ions and hydroxyl ions. So water has very low conductivity. You know, water can conduct electricity, okay, but that must be your tap water or something. Distilled water cannot, okay. So there is very low conductivity, all right. And if I talk about the electrolytes, when we dissolve electrolytes in water, they furnish their own ions in the solution, and due to the presence of those ions, the conductivity also increases, right? Because if there will be more ions, conductivity also increases. So what do we call that type of conductivity? So that type of conductance of electricity, that is by the ions. Okay, earlier it was by the electrons in the metals, but when it is by the ions present in the solution, it is known as electrolytic or ionic conductance. Okay. So this ionic conductance depends on the nature of the electrolyte, size of the ions produced and their solvation, nature of solvent and viscosity, concentration of electrolyte and temperature. So there are various factors on which this conductivity will depend. And one more thing, in the case of metals, the composition was not changing, but that will not happen in the case of electrolyte. Jab current pass hoga, then yes, the composition of electrolyte would definitely change. Okay, so that is the main difference between the metallic conductance and the electrolytic conductance. Okay.
So students, now let's talk about the measurement of conductivity of ionic solutions, right? So you know that the measurement of conductivity for metallic conductance can be done using Wheatstone bridge. Wheatstone bridge is something that you might have studied it in physics, but for ionic solutions, we cannot use Wheatstone bridge for measuring the conductivity. There are two reasons for that. So firstly, students, the first thing is that if we pass DC current through that ionic solution, it will change the composition of the solution. So we cannot pass it, and moreover, we cannot attach the solution using wire or some solid. Okay, so these are the two things why we cannot use Wheatstone bridge for the ionic solutions. But then there is another thing which is known as conductivity cell, which you can see in this picture, which we are using for finding out the conductivity of ionic solutions. Okay, the first thing is, students, that we will not pass DC current through it, we will pass AC current through it, so that the composition of the solution does not changes. And we are using this conductivity cell, in which there are two platinum electrodes coated with platinum black, which have an area of cross section of 1 centimeter square, and the distance between them is 1 centimeter. Okay, so here this is how this conductivity cell is connected, and we can calculate the conductivity of ionic solution using this conductivity cell. Okay, so students, the resistance will be given by rho L upon A. Okay, and rho you can write resistivity as 1 upon conductivity, 1 upon kappa into L upon A. Now this L upon A is known as cell constant. Okay, because we cannot calculate the value of length and area of cross section directly, but we can calculate the cell constant, and the measurement of cell constant and the resistance can give us the value of the conductivity. Okay, so this cell constant is denoted by G star. All right, so it will be G star into upon kappa. So here what we will be getting is kappa is equal to G star upon R. Okay, now you know that 1 upon R. What is 1 upon R? It is G. What is that? That is conductance, right? So it is conductance. So from here, kappa value will come out to be G into G star. So this is something that was written earlier also. Okay, which is your conductivity will be equal to conductance into the cell constant. Okay, so if we know the cell constant and the resistance, we can clearly find out the conductivity of the solution, of your ionic solution. All right, so this is the important formula. Keep that in mind, keep it noted. This is an important formula for you. Okay, because in electrochemistry formulas are very important. What I have found out is that most of the students face like some problems in solving the numericals. So if you know the formulas clearly and the concept behind it, okay, don't cram the formulas, just try to understand the concept behind it. That is why I am giving you the derivations as well. Okay, so this is the relation which was given here. Okay, kappa is equal to G into G star, where G star is L upon A, which is known as the cell constant. Okay, students. So this is the thing here. Now the thing is, students, that the conductivity of solutions of different electrolytes. So suppose if we have different electrolytes in the same solvent, suppose I am putting KCl or I am putting any other electrolyte like NaCl or something like that in your same solvent in water and at a given temperature also. So the conductivities for all the different electrolytes would be different because of the sizes and the charges of the ions in which they dissociate. Okay, solvent is same, temperature is same, but if the electrolyte is different, so in that case the conductivity would be different, no, because of the ions in which they are dissociating, they will be having different charges and different sizes as well. Okay, so the concentration and it will also depend on the concentration of ions or the ease with the ions which can move under a potential gradient. So that is why it is important for us to define a physically more meaningful quantity which we call as molar conductivity, which is denoted by lambda m. Okay, so what is molar conductivity? It is equal to kappa upon C. Now kappa, you know its conductivity, C will be the concentration. Okay, concentration of the solution. So that's what they are saying. Here we are talking about the units also. So the lambda m units will be Simon centimeter square per mole. Okay, all right, so you need to know that what is the difference between the conductivity and the molar conductivity. Okay, and if we are using Simon per centimeter, so in that case the unit would be Simon centimeter square per mole. All right. Okay, so Simon meter square per mole and Simon centimeter square per mole can be the units. Okay, so that's what was written here in this case, molar conductivity. So kappa into volume. So you can say volume like nothing but the concentration. Okay, so concentration we are taking in this case. All right, so that's what is the molar conductance. Now let's move on to the next topic. Now students, let us talk more about it. So variation of conductivity and molar conductivity with concentration. This is very important topic that you must know. Okay, now the thing is that both the conductivity and the molar conductivity, they will change with the concentration of electrolyte because that will depend on the number of ions, right? So if concentration of the electrolyte changes, means the number of ions changes. So that will change the conductivity and the molar conductivity. So conductivity always decreases with the concentration, decrease in concentration, both for weak and strong electrolyte. Keep that in mind. Okay, if the concentration of the electrolyte decreases, so obviously there will be lesser number of ions per unit volume. Okay, means एक unit volume में कितने ions present हैं, so that is going to decrease ना, because the ions are the ones that are carrying the current. So अगर ions ही कम हो जाएंगे तो obviously the current will also become less ना. So if we are diluting the solution, means if we are decreasing the concentration, so the number of ions that are present per unit volume will decrease. Okay, I hope you are understanding it. Okay, so the conductivity of a solution at any given concentration is the conductance of 1 unit volume of the solution kept between two platinum electrodes with unit area of cross section and distance of unit length. ये हमने अभी discuss किया है, right? तो conductivity is something, it means the conductance, or you can say the conductance of 1 unit volume of solution. We are taking 1 unit volume which is kept between 2 platinum electrodes जिनका area of cross section के आधा हम unit लेंगे, like means 1, and the distance is unit length. So यहाँ से आप देख सकते हैं that conductance is equal to kappa into A upon L. All right, now A and L are unity, so the conductance is equal to the conductivity only. Okay, so this is about the conductivity, the variation of conductivity with concentration. All right, now if I talk about the molar conductivity of the solution. Now molar conductivity, I told you it's dependent on the concentration. So it is actually the conductance of the volume V of a solution containing 1 mole of electrolyte kept between 2 electrodes with area of cross section A and distance of unit length. Okay, so we are saying कि if 1 mole of electrolyte is present in volume V of the solution, so in that case whatever conductance is there, that will be equal to the conductivity of the solution. Okay, so from here students, you can see that lambda m will be kappa into A upon L. Now A and L are this thing, your 1, so it will be equal to kappa. Now the volume containing 1 mole of electrolyte. So here they are saying कि area would be equal to V. Okay, so in that case अगर इसको आप यहाँ पर don't write it as kappa, so instead of length is 1 and A would be the volume, means volume containing 1 mole of electrolyte. So lambda m would be equal to kappa into volume. Okay, means that volume which is having 1 mole of electrolyte present. All right, so now students, the molar conductivity, it increases with decrease in concentration. This you have to understand now. जो normal conductivity थी वो क्या हो रही है? It is decreasing with the decrease in concentration because the number of ions per unit volume are becoming lesser that are carrying the current. So in that way the conductivity decreases. But if I talk about the molar conductivity, so molar conductivity के case में क्या हो रहा है? The total volume of the solution which has 1 mole of electrolyte is increasing. अब suppose हम किसी solution को dilute कर रहे हैं. Earlier it was having 100 ml, let's say. Now we have made it 500 ml. So the volume is increasing, na? The volume which is carrying that 1 mole of electrolyte is increasing. Okay, and just now we have seen कि the molar conductivity depends on the volume. So अगर volume increase हो रही है, so that means the molar conductivity will increase. Right? I hope you are understanding this thing. From the formula try to understand कि molar conductivity क्यों increase होगी, because the total volume of the solution which is carrying 1 mole of electrolyte also increases. Okay students, and it has been found out that decrease in kappa, means decrease in the conductivity on dilution, is more than compensated by increase in the volume. So what does that mean students? That lambda n can be defined as the conductance of electrolytic solution which is kept between the electrodes of a conductivity cell at unit distance, but having area of cross section large enough to accommodate sufficient volume that contains 1 mole of electrolyte. Okay, तो मतलब जो decrease in आपका conductivity है on dilution, it is more than compensated by increase in its volume. Okay, तो area of cross section हम इतना मान के चल रहे हैं that is large enough to accommodate sufficient volume which can contain 1 mole of electrolyte. Okay, कि हम उतनी volume वहाँ पर increase कर सकते हैं. Now when the concentration approaches 0, this is again important. So जब concentration जो है वो 0 हो जाएगी students. When the concentration is 0, the molar conductivity is known as limiting molar conductivity. Okay, लिमिटिंग मोलर कंडक्टिविटी लैम्डा एम नॉट से हम इसको रिप्रेजेंट करते हैं. मींस जब हम उसको पूरा डाइल्यूट कर देंगे सच दैट द कंसंट्रेशन बिकम्स अप्रोचेस टू 0, मींस बहुत नेग्लिजिबल रह जाएगा. सो द कंडक्टिविटी इज नोन एज लिमिटिंग मोलर कंडक्टिविटी. एंड नाउ वी विल बी सीइंग द वेरिएशन इन लैम्डा एम, मींस द मोलर कंडक्टिविटी फॉर स्ट्रॉन्ग एंड वीक इलेक्ट्रोलाइट. सो अलग अलग फर्क यहाँ पर रहेगा. Now for strong electrolytes, lambda m increases slowly with dilution and can be represented by the equation. So हम क्या equation लिखेंगे? Lambda m is lambda m naught, which is limiting molar conductivity, minus AC raised to power half. So इसका actual में हम graph देखते हैं. So students, we are actually plotting the lambda m value with the C half, okay, and we get a straight line with the intercept equal to the limiting molar conductivity, and slope is minus A. Now this A is a constant for a given solvent, and at a given temperature its value will depend on the type of electrolyte, like which electrolyte we are taking, okay. That is the charges on the cation and anion produced during the dissociation of the electrolyte. Like for NaCl, it's 1 minus 1, and for calcium chloride it's 2 minus 1, and for MgSO4 2 minus 2. Okay, so all electrolytes of a particular type, they will have a same value. For A, you can look at the graph, see. So here we are plotting the lambda m with the C half. So the intercept would be equal to the limiting molar conductivity, and slope is minus A. You can see the negative slope in this case for KCl, which is a strong electrolyte. Okay, we are talking about strong electrolyte. The other graph is for weak electrolyte, which is acetic acid, that we will also discuss. So this happens for the strong electrolyte. Now Kolash actually examined the limiting molar conductivity values for strong electrolytes, and he observed certain regularities. He noticed that the difference in lambda m naught of electrolytes which are of the type NaX, Kx for NaX is nearly constant. कि जो limiting molar conductivity है for NaX and Kx type electrolytes is nearly constant. Like यहाँ पर देखिए for KCl minus NaCl, so it will be KBr minus NaBr. So here you can see the values are almost similar to around 23.4 Simon centimeter square per mole. Okay. Now the above observations, he gave us the Kolash law of independent migration of ions. Now this is something very important. So it says, students, that the limiting molar conductivity of an electrolyte can be represented as the sum of individual contributions of anion and cation of the electrolyte. Okay, like if lambda naught and lambda naught Cl are the molar conductivities of sodium and chloride respectively, so the limiting molar conductivity for NaCl will be the sum of limiting molar conductivity for the sodium ion and limiting molar conductivity of the chloride ion. Okay, so in general, if electrolyte gives this much cations and V minus anions, so the limiting molar conductivity is given by this formula. You have to multiply it with the number of ions produced. So NaCl के case में तो the value of nu plus is 1 and this is 1 again. Okay, so इसलिए we have written it directly. And these are the limiting molar conductivities of the cations and the anions. Alright students. Now if I talk about the weak electrolytes, so now weak electrolytes like acetic acid, they have lower degree of dissociation. You know कि in the case of weak electrolytes, only few molecules they dissociate, okay, at higher concentrations. And then for such electrolytes, the change in molar conductivity with dilution is due to increase in degree of dissociation. अब यहाँ पर जो आपकी लैम्डा एम है वो चेंज हो रही है, वाई? बिकॉज जैसे जैसे आप वॉल्यूम बढ़ाएंगे, राइट, इफ यू आर इंक्रीजिंग द वॉल्यूम, इफ यू आर डाइल्यूटिंग द सोल्यूशन, सो डिग्री ऑफ डिसोसिएशन बढ़ेगी, बिकॉज दिस इज अ वीक इलेक्ट्रोलाइट. तो जैसे वॉल्यूम बढ़ेगी, द डिग्री ऑफ डिसोसिएशन विल also increase, so the number of ions in total volume of the solution will also change, right? तो क्या होगा, lambda m will increase steeply. Firstly, lambda m जो है आपकी the molar conductivity will increase on dilution, especially near lower concentrations. Okay. So lambda m naught cannot be obtained by the extrapolation of lambda m to zero concentration. So यहाँ पे हम extrapolate करके we cannot find out the value for the lambda m naught. यहाँ पर तो हम extrapolate करके we can find the intercept ना, but in this case we cannot do. You can see at lower concentrations the limit this thing conductivity is very high, because जैसे जैसे आप डाइल्यूशन करेंगे द नंबर ऑफ आयंस और द डिग्री ऑफ डिसोसिएशन वुड इंक्रीज एट इनफाइनाइट डिल्यूशन. अब इनफाइनाइट डिल्यूशन की बात करें वेयर द कंसंट्रेशन अप्रोचेस टू जीरो, तो उस केस में actually we consider that the electrolyte dissociates completely. Alpha is 1, degree of dissociation is 1, but at such lower concentration जो conductivity है it is so low that it cannot be measured accurately. So for the lambda m naught limiting molar conductivity for weak electrolytes हम use निकाल सकते हैं using the Collar's law. Okay, so at any concentration, students, if alpha is the degree of dissociation, then it can be approximated to the ratio of molar conductivity to the limiting molar conductivity. So alpha is lambda m upon lambda m naught. Okay, so for weak electrolyte like acetic acid, you will see जब हम equilibrium chapter करेंगे, you will see this. So the Ka like the equilibrium constant is C alpha square upon 1 minus alpha. तो हम alpha की value यहाँ put करेंगे and you will get this relation. Okay. So what are the applications of Collar's law? Using Collar's law of independent migration of ions, we can calculate the limiting molar conductivity for any electrolyte from the limiting molar conductivities of the individual ions. हर ion की limiting molar conductivity से आप electrolyte की limiting molar conductivity निकाल सकते हो. And like for the weak electrolytes like acetic acid, we can find out the value of dissociation constant अगर हमें lambda m और lambda m naught की value पता हो at a given concentration. Okay. So students, I am giving you a question to solve here. So here the conductivity of the solution of 0.001028 mole per liter acetic acid is 4.95 into 10 to the power minus 5 Siemens centimeter. So here they have given you the conductivity, okay, into 10 to the power minus 5. You have to calculate the dissociation constant if lambda m naught is given. Okay, limiting molar conductivity be given hai. So what you will do here, firstly you will find out the value of degree of dissociation alpha, which is lambda m upon lambda m naught. I am telling you how to solve it. Then dissociation is C alpha square upon 1 minus alpha. तो C की value भी यहाँ पर आपको given है, concentration is given, alpha you will calculate and you can tell me the values. So again I want all of you to give the answers in the comment section. I'll be waiting for your comments for both the lectures, okay, for the first one and for the second one as well. Okay students, so this is how to solve it. Please do solve it and give me the answers in the comment box. Okay, so we will be meeting in the next lecture of electrochemistry. That will be the last lecture where we'll be talking about the electrolytic cells. Okay, that's a small one. So we'll be talking about electrolytic cells and batteries. So until then students, take care, keep learning, bye bye.